All right, well, let's make a wind tunnel. So I have Fluent, or I have the workbench open as this workbench, and let's go ahead and create a new module for Fluent. Here in block A, I already went through and made it already. And something cool I figured out right before recording this is when you're dragging out a new block, you can create a new standalone system, or you come through if you want to use the same geometry and the same mesh, then you can. And you see in that block, it now says share A2 to A3. You can all go all the way up to solution. So that's pretty cool if you want to like just change like a couple of parameters. But since for the purposes of this video, we're going to go ahead and create a standalone system. All right, so now we have our Fluent block open. And you can create your geometry using whatever you want: Space Clean, Design Modeler, any other CAD program you want and import it in. I'm going to do Design Modeler. It's going to take a second. All right, so we're going to do a 2D plane. 2D, yeah. So when you're sketching your wind tunnel, when you draw out a line and you see this H here, that means horizontal, so even it'll snap to horizontal. So even though right now you can see that it's slightly at an angle, when I click, boom, horizontal. How cool is that? Same thing with V, it'll snap to vertical. All right, oh, before I go any further, I want to make sure I'm in the right units. So up here on the toolbar, go up to units and use whatever units you want. I'm gonna use inch. Okay, so now that we've created our sketch, we're going to go ahead and create a surface from the sketch. So to do that, we're going to go ahead and go up to the toolbar, concept, down to surfaces from sketches. Now I'm going to go ahead and on this the tree outline, click my sketch, bottom left, now click apply. It should. Did not. Oh, you have to click generate. That's right. So after you highlight your sketch, you should click generate so it generates your shape. So here we have our wind tunnel. So you can see since it's shaded in, there's no open parameters. If one of these corners didn't connect, then there would be no surface. So that is a good way to know if you got it right. All right, so we're done here. So I'm going to go ahead and save it. X out. We're going to go back to our workbench. And now we can see here, we have a green check mark. That means we're good. Let's open up our mesh. Takes a second to bring in your geometry. All right, here we go. And you can see we have our wind tunnel here. So let's go ahead and look down the z-axis again, because we're only doing 2D. We don't need to worry about any 3D. All right, so let's go over to our mesh. We're going to insert method. So let's select our geometry, apply, and we're going to go ahead and use triangles. Now you can see there's mesh, there's some triangles. If we go back up, click our mesh here on the bottom, we can see our details page. And I'm going to go ahead and change my element size. I'm going to do 0.01 meters. Now you can see, now that we've changed our element size, you can see the mesh is now purple, which means it's an obsolete mesh. Then we're going to go ahead and generate, get our updated mesh. Might take a second. And here we can see our mesh. I'm going to zoom in a little bit. You can play around with your mesh, try to fine tune it some more. The more meshes you have, the more accurate answer you're going to get. Let's go ahead and let's do 0.001. Go even smaller. Sometimes it doesn't really work that great. So I'm gonna go ahead and I'm just gonna stick with 1.01. And it's important to note that right now we're in metric. You can always come down here and change your units. But we did the sketch. I did the sketch in inches, but I can come in here and work in metric. So it's just important to always be looking at your units. Okay. I think this is good. Okay, so now that we have our mesh, we can go ahead and create our named sections. So if you click on the mesh, you can see the mesh, but we're going to go ahead and click back on model to see our model. And we want to be able to set where our inlets and outlets and where our boundaries are. So I'm going to select my inlet, go down to create name section, and I'm going to name it inlet. And you can just repeat, or you can just click on it and press N on the keyboard. That's the shortcut. You want to select multiple items, go ahead and click and with Shift selected. Okay. So now we can see we have our inlet, we have our outlet, we have our tunnel walls, and we have our mesh. So we're good. Let's save this. Then we can go ahead and exit out of here once it's saved. Now we're going to go to our setup. Oh, wait, before we do that, let's go ahead and make sure we're updated. You can see the little lightning, that means we need to update. So might take a second. All right, now we have a green check mark. We're good to go. Let's set it up. We'll do double precision. We'll go ahead and do 2 solver processes. We're in 2D. It already knows that. So let's go ahead and start. All right, this is the fun part. All right, so to get familiar with this page, here we have our mesh imported. You can see the blue lines coming in our inlet, red lines coming out of our outlet. So that means we set that up right. Down here at the bottom is our console and our outline view and task page on the left. All right, so I just checked my mesh. Looks like it's fine. Didn't tell me any issues. Here's where you can change the units. For example, let's go down. Our energy is going to be in joules. That's good. That's good. Frequency in hertz. I want to change the length. I want our length to be in inches. Everything else is good. All right. So start off, let's turn on energy. So for this, we want to have a turbulent flow. So we're going to use anything but the top 2 in Visitor Laminar. Let's do K epsilon. Let's do enhanced wall treatment. Turn on our pressure gradient effects. Leave everything how it is. Okay. Make sure we're pressure based because we're in a subsonic flow. If you have a supersonic, you're going to go ahead and click that density based. We're good there. Make sure our fluid, we're working with air. Density is correct. Don't need to change any of that. We're good. Good. I just like to open them up and check to make sure. No rotation. All right, and so for our velocity, I have a, for what I'm gonna be using, I'm gonna go ahead and do 0.2352. All right, 300 Kelvin, that's good. We're a stationary wall. It's good. That's good. Here's where you can change your reference values if you need to. I'm just going to change this to 300. Okay. Now this, just make sure that we're working right. I'm going to use Presto for pressure. Okay. Now we got to our initialization. I'm going to do a hybrid initialization. Excuse me. We'll do 35 iterations. It's initialized. You can see down in the console, it is initialized. And let's go down and we got to run our calculation now. We do 500 iterations. I've noticed that it usually converges somewhere between 100 and 200 iterations on my machine. So it just depends on your computer. All right, let's calculate it. So you can see down here in our console, it's running our iterations, and you can see the residuals being scaled up here. Calculation is complete. Get that tape. 232 iterations. Nice. Cool. All right, now we come down here to our graphics. This is where we're going to get our contours under results, graphics, contours. No, it's static pressure. 10 hertz because that's what my assignment is. You're just going to select everything, click compute, and it'll show you your maximum static pressure and your minimum. Save display. Boom, there we go. You can go play around. You can see different values. You can see your dynamic pressure, compute. There you go. Yeah, you can see like dynamic pressure is much higher here in the test section than it is in our anywhere else really. Let's check our velocity. Yeah, velocity is highest here in our test section. And you can see along the walls the no slip condition. So, and we can see our plots. If we go down here to XY plots, if you want to get along the center line, you want to get, let's say velocity along the center line of your wind tunnel. You're going to go down to XY plots, select velocity. Now we're going to need a new surface and make a new line. We're going to title it center line. And since I went ahead and set my units in the beginning to inches, I can go ahead and set my inches here. It should be 40, it's 42.5. Let me double check that. 46.5. I have to make that negative because I put the origin right smack in the middle of the test section. So if you put your origin here on the leading edge, on the the inlet, then you can just plug in 0 for x0 and then the total length for your x1. And here you go. Here's the velocity magnitude along the center line. You can see it's pretty low. The inlet increases into the test section, which is here around 0. Decreases as it leaves the it leaves. So All right, that's how you do a test or a wind tunnel, subsonic wind tunnel in Fluent.